Bonjour et bienvenue. Welcome to ChangeNOW at the fantastic, wonderful Grand Palais. Quick show of hands. Who has been in this wonderful location before? Just to get a sense? Oh, okay. A couple of you. Very well. Welcome to the first of many pitching sessions at ChangeNOW about the topic of energy. Energy is life. It's all around us. Without it, much of the reality that we know wouldn't be possible. But the ways how we source energy, distribute energy, use energy has been, as we know, destructive to the planet, to the biodiversity, and ultimately to us humans. So in today's pitches, we're going to look at a new way of generating, distributing, using energy from many, many different perspectives. And we have with us a wonderful jury that's going to ask a couple of questions in the Q&A after the pitches. And to know who you are, I'm going to pass the microphone to you for just a 20-second or so per person introduction to yourself. Wonderful. It's good to have you. Thank you.
Hello, my name is Zoé Constantin. I'm in a fund called Impact Catalytic, and we are investing in European impact startups.
Wonderful. Good to have you.
Hello, I'm Marie Fessel. I'm a design and trademark attorney at Place4 IP, and we help companies protect their innovations through patents, trademarks, and designs.
Cool. Great. Good to have you.
Good morning, everyone. I'm Thomas Bruno, Executive Director of Cleantech Open France. We help startups and SMEs to develop their activity in France, and we have 600 startups and SMEs and 100 partners.
Wonderful. Good to have you.
Hi everyone, I'm Morgan Scheel, head of impact at World Fund. We're a 300 million euro fund that invests in climate tech. Specifically, we focus on startups that have significant potential to reduce emissions.
Great.
Hello, I'm Clément Auchard, and I'm a founding partner of Scoby Collective and Scoby Venture. And we are an acceleration studio accelerating globally a startup from pre-seed stage, and also investing or creating ecosystem to invest in startup.
Wonderful. Good to have you.
Wonderful. And I'm Kate Burson. I'm a partner with Radiate Capital, and we're focused on growth equity for industrial decarbonization, energy, transportation, building materials, et cetera, focused on Europe.
Okay, wonderful. A knowledge and expertise-packed jury. It's good to have you, and welcome everyone in the audience. What we're going to do is to see 5 pitches, 3 minutes each, followed by a Q&A session, then followed by another 5 pitches with 3 minutes each, followed by another Q&A session. And without further ado, I'd love to ask the first speaker on stage, and that would be Nick Hazel from Algenie. Welcome, and the stage is yours.
Thank you. So I've just been listening to Mary Robinson, wondering why is it that we're not acting now after the Paris Agreement? And the reason is because of economics. We're not going to make the planet sustainable unless there's an economic reason to do it. And I'm facing into that as well with Algenie. This is not my first rodeo. I founded the leading plant-based meat company in Australia, which is where I'm from. The scientists know that you can make everything from algae. In fact, fossil fuel crude oil is old algae. And if we can do that, there will be an enormous planetary benefit because everything you grow with algae absorbs CO2. The trouble is economics. It's way too expensive. Today's algae tech is not viable, nor is it scalable. If you wanted to do a gigaton with ponds, you'll have to flood France. It's not viable or scalable today. That's where Algenie comes in. We have invented helical photobioreactors that can get us realistically to $1 per kilo of biomass. Why $1 a kilo? Well, that's what the cost of crude oil is per barrel. We can scale to gigatons by 2030, and we don't need land. 10,000 tons per hectare with our revolutionary helical photobioreactor. And what makes us different? We have the bioreactor, and we've already designed it for mass production. I can produce these helices on an extrusion, and we've patented that as well. We can do that at massive scale. And we've also developed the AI to optimize the strains of algae that grow uniquely productively on this photobioreactor. This is a true invention. And we work perfectly with renewable energy because guess what? Algae don't mind when the lights go out. They're kind of used to it. So we can turn our lights on when renewable energy is available, and we all know that renewable energy is spilling its energy a lot of the time. So we can work really well with renewables. And we will create a new biotech industry as a result of this. We're cheaper than yeast and bacteria. We absorb CO2. We don't use up land. We don't need sugar to feed the algae. All they need is energy and CO2. And this will become a new biotech industry to create all of the chemistry that we currently get from fossil fuels. We're selling minis to labs around the world so that they can start experimenting with our technology, and we'll be starting to scale within the next 4 to 6 months. We're revolutionizing algae production for a sustainable economy, and we're making it economic to sequester gigatons of CO2 into the stuff that we make, buy, and use. Thank you very much.
So, thank you so much, Nick. That was wonderful, setting the scene for everyone. And right on time, 3 minutes. That's just how we love it. The next pitcher will be Felipe Ariola from BioEsol. The stage is yours.
Thank you. Thank you all. I am Felipe, co-founder and CEO of BioEsol. We help small and medium businesses to secure energy supply and reduce energy costs with all-in-one energy combination that requires generation, storage, management, and financials. Sound launching in 2021, we have been shown a strong and consistent traction. Last year alone, we have achieved 5.1 million in revenue with more than 200 clients, including Enel, and we have been profitable since year one. We're a team of proven climate-tip founders with deep experience in the energy as a service model and successful exit. We are backed by top-tier experts and scale-up leaders that are helping us to scale this company in a new direction. This year, we are projecting to reach 50 million in annual recurring revenue, and by 27, we aim to hit 100 million, equivalent to 1 billion in energy contracts. Let's talk about the problems. So in Europe, number one threat is the grid congestion that is obstacling the energy transition. Electricity price and volatility are rising and putting SMBs under pressures. The solution on-site decentralized energy systems, and this is where BioEsol comes in. Our business model includes 3 revenue models: software as a service, AI-powered energy intelligence, one-time project for tailored energy projects, and energy as a service. Generation, storage, management, and financial solution. Unlike other most competitors that focus on residential market and rely on off-the-shelf battery solution, our platform is tailored for SMBs. Our competitive edge is proprietary technology, focused market fit, and a scalable business model. We are targeting a growing market, growing at a 20% annual growth rate. And we plan to serve 10,000 SMBs in Europe and 3,000 in Latin America. We have a clear map to achieve this with 3 strategic partnerships with Enel, BYD, and Siemens to scale the company.
Thank you. Thank you so much, Felipe. Wonderful. Thank you. Appreciate it. Next up is James with e-Zinc. Tell us what that's all about. Stage is yours. Thank you.
Good morning, everyone. My name is James Larson. I'm the CEO of e-Zinc, a Toronto-based long-duration energy storage company. We all know that carbon is a problem, and one of the major ways to solve this is with renewable energy. But renewable energy is intermittent. And a lot of people focus on the daily cycling challenges of renewables. But if you actually want to enable a fully renewable future with high penetration of renewables, you need long duration storage capable of multiple days of storage. The US Department of Energy, I think, illustrated this the best. This is a synthesis of their study looking at storage duration, hours at rated power, and versus how much renewables you have on a grid. And there's a clear correlation. The more renewables you have, the greater the imbalance in the supply and demand. And batteries, which are good up to maybe about half a day, are no longer going to be that useful. And we're going to need technologies like e-Zinc to solve this problem. This is a $4 trillion market by 2040. As Wayne Gretzky in Canada likes to say, be where the puck is going. So we've developed a proprietary zinc-based solution that stores energy in physically free zinc metal. It's a containerized solution, entirely modular, and we use cells that store energy in physically free zinc. It's low cost. Our systems are a fraction of the cost of lithium ion. We can right-size the design of a system to be exactly what a customer needs in terms of duration, 10 to 100 plus hours. We have over 15 years life in field. We're entirely safe. There's no risk of fire or explosion. And we're sustainable. Every item on our bill of materials has an existing recycling market or can be reused in subsequent generations of systems. The journey's been very exciting. In 2019, we raised our seed round, and we won Breakthrough Energy Solutions Canada, which was a partnership between Breakthrough Energy Ventures and our Canadian government. That's when we designed our first cell. We then raised a Series A1 round with Toyota Ventures, NEXT, etc. And that allowed us to deploy our first system in the field. This was at a compressed natural gas facility, demonstrating a holistic energy storage system using both solar and the grid. We then raised our A2 round, Evoque, as well as Mitsubishi Heavy Industries. We grew the team. And last year, we just built our first manufacturing facility in Ontario. And so excitingly, we're now building our first commercial projects with the California Energy Commission and Toyota Tsusho. So going forward, this year and next year are all about our first-of-a-kind commercial projects. These are going to be the world's first 24-hour duration battery energy storage systems, a huge stake in the ground for our company. We're then going to be raising our Series B round, and in 2027, we'll be establishing our first scale manufacturing facility and doing bankability, and then moving full commercial. Thank you very much for your time.
Thank you. James, thank you so much, James. My head's spinning already with inspiration of what's possible, but there's more to come. That was just 3 out of 10. And the next up is Carlo Charles from Flint Paper Battery. Your time to shine.
Hello, I'm Carlo from Singapore, and I'm happy to share about Flint. What we're building is a new battery chemistry that has no toxic and scarce materials like lithium, nickel, and cobalt. What we use instead is the cellulose that you find in paper as a central component of the battery, which combines the electrolyte and separator into one component. We take that component and we coat our anode and cathode materials on top of it. And if you think about it, it's actually very similar to how lithium batteries work. But the only difference is we don't have lithium, nickel, and cobalt. Our chemistry is completely different. And the key benefits that we get out of it is, number one, the cost efficiency. Our input materials are up to 90% lower compared to lithium chemistries. And then when you scale it up to production, lithium ranges from $100 to $130 per kilowatt hour. We are at $50 per kilowatt hour right now. The next one is safety. We don't use any acids. We don't use any high concentrate electrolytes. So we use water as our electrolytes. And because of that, the batteries are very safe. They're leak-proof. They're fire-resistant. You can even cut the battery while it's in operation. It will still continue working. It will not overheat. It will not combust. No sparks. And the next thing is the sustainability, where our carbon footprint is up to 90%, 95% lower than lithium chemistries. And that's because of two things. Number one, the materials we use are very abundant. And number two, the end of life of these batteries are compostable. And as you can see here, within 6 weeks, the batteries can degrade and go back to nature. Well, this doesn't mean we're asking everyone to go around and throw batteries. No, this means that recycling will be so much easier and cheaper in the future. Well, we started in early 2019 as a passion project. And now we reached TechCrunch, Disrupt, and we just broke Stealth at CES earlier this year in January. And that's also where we got the best of CES recognition alongside NVIDIA, LG, and Honda. So now we are working with a lot of companies to build these batteries into their products. We can talk about coin cells, cylindrical cells, pouch cells, prismatic cells. And as we move towards near towards production, we would love to expand our horizons and see more companies who we can work with, because most of the companies we've been working with are mostly American, and that's why we're here in Europe to share it with the European market, and would love to see who would be interested. If you'd like to learn more, we're just right there, like just right beside, so you can come and talk anytime. Well, we have a small saying in our company. It's like, we're building the big future of batteries, and we're starting it small. So yeah, thank you very much for your time.
Thank you so much, Carlo. Building something big, but starting small. That makes a lot of sense. Next up is Daniel Palm from HalioGen Power.
Thank you. Good morning, everybody. My name is Daniel Palm, CEO and co-founder of HalioGen. Now, you may be wondering, who's HalioGen Power? We are ultimately the new kids on the block who have already been recognized as one of Europe's top 100 companies or startups within the first year going. So what are we all about? It's about intermittency. We already have heard about this morning. We are the guys who will be making renewable energy accessible to anybody, anywhere, anytime, at the most affordable cost. So why do we need that? Intermittency is an issue in the market, as we've already learned today. Renewable energy is not always available when we do actually need it. So we will be overcoming this problem. Why is this important? In the UK alone, we have seen this costing 20 billion a month in energy curtailments, as well as energy costs, or energy imports, so to speak. So huge topic. So we are bridging the gap, especially for solar power, to bring it from peak times to when it's actually really needed. So how do we ultimately do that? My colleagues at the University of Manchester came up with a breakthrough innovation where they, very similar to a yin and yang principle, managed to combine the plus cycle and the minus cycle into a single flow circuit system. This simplifies the system from 2 tanks into 1 tank based on the cheapest electrochemistry we're seeing out there in the market. It's an 85% water-based system. It is safe, it allows for scaling, we are focused on a 10 to 15 hour energy shifting mode, and from a performance perspective, we are not shying away from lithium batteries, aiming to be pushing into the 90%. We will have an incredibly wide operating temperature range, allowing us to operate in the cold from minus 10 degrees, but also to plus 55 degrees, a novelty in the market. We are non-flammable, and we are fully recyclable once we're there. So whom are we for? Ultimately, everybody who wants to electrify. And we've heard this is a huge topic. So this in mind, we do have a very clear strategy. It's a huge market. We will be pursuing a phased approach, focusing on medium customer player or industry players first, going to mid to heavy industry and large-scale utilities with a clear business model behind. Are we alone? Nope, absolutely not. But we do stand out based on our no-membrane system, which will be more affordable and cheaper than anything else we do see in the market. So we have received a lot of traction and momentum in the market already from partners being funded by the German government at the moment via their Federal Agency for Breakthrough Innovation. We have part of a number of accelerators, but also we are receiving a lot of commercial traction with our first conditional offtake agreement being signed as we speak. We are a strong team based on science as well as commercial business expertise. And thank you.
You can keep it. Thank you. That was Daniel, and the last of the first 5 pitches, with 5 more to follow after a Q&A session. To that end, I would love to ask all the 5 pitches back on stage and line up here with me. And looking at the jury, I wonder if you had any questions to these entrepreneurs and founders. Please.
Hi, I have a question for Algenie. Do you have a guess on what would be the first? Do you have a guess on what would be the first chemical product that will be based on your product?
Yeah, there's already a big market for high-end pigments, but the thing that's interesting is things like PHA, so bioplastics. It could do about 70% of plastic could be done with PHA if you can get the cost down to about the cost of polyethylene. And in our analysis, we can get to about $2.50 a kilo, which is, you're in the ballpark of polyethylene. At the moment, PHA is 10 times that, which is why bioplastic is not actually a really big industry. So I think that would be the most interesting, because then you can imagine all of your plastics, all of your polymers, everything you're wearing is going to be embodied CO2, and that's where you can start talking about gigatons of CO2.
I have a question for Flint. How long your battery lasts compared to classic lithium battery?
Yeah, thank you. So we can measure it in two ways. Number one is density of the battery. Lithium is from 200 to 300 watt hours per kilogram. We are 226 watt hours per kilogram already. And in terms of life cycles, lithium ranges from 500 to 2000. We are at 1000 right now, 1000 to 1500. Yeah.
I have a question to Flint Peter Battery 2. You must need your carbon footprint.
Yeah.
You measure your impacts of biodiversity or not?
Sorry, I could.
On biodiversity.
Which did you
Biodiversity.
Biodiversity.
Sorry for my accent, French accent. You measure your carbon footprint, and do you measure your impact of biodiversity?
Oh, yeah, thanks. That's a good question. So we do cradle-to-cradle approach all the way from raw materials till end of life. So we take into account every single, like from the production to manufacturing to shipping to logistics, even all the way till the consumer is using the batteries because it's rechargeable also. So yeah, we do, yes.
I've got a question for e-Zinc. In a past life, I was a former investor in Form Energy, who is targeting also 100 plus storage hours. They've seriously struggled with scale up and commercialization issues. So I was wondering what you guys are seeing in that space and if you have any utility partners that you're working with.
Yeah, so a few things. Number one, Form Energy has a fixed power to energy ratio. It's 100 hours. They can't break from that. Ours is a flexible system, so we can right-size the design to be 24 hours, 48 hours, 100 hours, or longer. That's one major difference. Second is, when I first joined this company, I'm not the founder. I'm a mechanical engineer, and one of the things that I looked at, I was like, this manufacturing has to be scalable. And our IP is in the process of metallizing energy. We use everyday commodity materials and components and everyday engineering processes. Our COO is an expert in contract manufacturing, and we use a CM model actually to make our systems. So it's a capital light, rapidly scalable business model.
Yeah. Great. I have a question for BioEsol. Closer. What are the capital sources like in structure in terms of financing these projects for the SMEs?
Yeah, so the first debt facility that we raised was 10 million, and we raised it through venture debt. Actually, our lead investor in the last round that we closed in the 50 million, he provides this 10 million. And right now we are working with traditional lenders like banks, private equity. So right now we already have a 50 million term sheet from the bank, and we are looking to work with private equity companies and other lenders that can provide us. We have a sales pipeline of 150 million right now, so we require a lot of powder to attend the market.
Great, and everything's on balance sheet.
Yeah, no, actually we structured an SPV, a master SPV to deploy the debt, so it's not in our balance, and all the assets remain in the SPV. Thank you.
I have a question for Algenie. What is have you kind of seen any challenges on the maintenance, and how do you collect the algae when it's in your process?
Yeah, so when algae is happy, you can run it continuously. We've run for more than a couple of years continuously. You continuously harvest it, so you get your system at optimal, so the right concentration of algae, the right light, the right CO2, and once it's set up, you keep running. What is beautiful with algae is that because the only thing it needs is light, no other microorganisms can grow. So you don't have the same problems with other biotech that, other things eat the sugar and grow preferentially to the thing you're trying to grow. With algae, the only thing that grows is the algae, and that means you can run continuously. So the idea is you keep going. And in other systems, we've managed to run for 3 years in a tubular system, and we believe our helical system will be able to do the same.
Okay, and what algae are you growing? What algae are you growing? What species?
Well, we've only tested 2. So just to be really clear, we're the picks and shovels. So we produce the photobioreactors. It'll be able to grow any sort of algae, salt or fresh water, any cyanobacteria, which is faster growing than algae, so it's going to be more cyanobacteria. But we're going to be doing the picks and shovels for thousands of potential candidates. We believe, though, it'll be a couple of chassis that will then be using the biotech tools to create the chemistry that you want.
Okay.
I've got a question for HalioPower. You said you're targeting industry and large-scale utilities. Those often have long sales cycles, so I was curious as to what your current sales cycle looks like, or what you anticipate that sales cycle being.
Yes, generally speaking, we basically will have a phased approach based with our scale, or aligned with our scaling strategy, so to speak. We will be having a solution which will be lasting for 25 to 30 years at the end of the day, which certainly is in line with some of their investments at the moment. But the utility scale or the utility grid scale applications are not the first step in the market. However, we are already speaking with a lot of them, trying to make sure that we are in the right place at the right time. Does that answer your question?
Curious, what does your current sales cycle look like? Like, how long is that?
The sales cycle?
Yeah, not just for the utilities, but also like industry.
Well, from a sales cycle perspective, we are early stage prototype at the moment. We are targeting 20 to 25,000 cycles at the moment, aiming to push it towards 30,000 cycles.
Anything? No? Okay, yeah. Very, very short one.
Just quickly, same company. You selected your markets are France and Mexico. I was just wondering why those are your first markets.
Okay, so, well, we started in Mexico operating, and then 2 years ago, we moved to France to Grenoble to set up the R&D office. And now we are relocating our holding companies to France.
Okay, wonderful. Please put your hands together for the first 5 pitches. Very courageous, starting the day and the conference. Thank you very much. And they will be rejoining the jury after the next session in the networking area for more opportunities to question and answer. Welcome everyone to those who have just joined us. We are in the first of many pitching sessions at ChangeNOW that will run all the way until Saturday. And this session is all about energy. And we are having another 5 rounds of pitching right now, and kicking off will be Joel Tai from Finks. Oh, sorry, that will be Manuel Sai from MPower. Yeah? Okay. Stage is yours. Manuel, please.
Perfect.
Thank you.
I'm Manuel from MPower. Today, about 500 million people in Africa still lack access to electricity. But there are many more that are connected to the electricity grid, but experiencing power cuts on a regular basis. At the same time, we have witnessed a drastic drop of solar panel prices as well as battery prices. So this lack of electrification, combined with falling technology prices, is really a window of opportunity where we at MPower, we come into play. We are convinced that Africa is leapfrogging to a world of decentralized energy as we speak. Against this backdrop, we came together and we created a B2B platform providing turnkey solutions to local installers and local distributors in Africa, enabling them to deploy solar energy to their end clients. So we're combining our expertise with the expertise of local distributors, and we decided to set up ourselves as a B2B business and don't go into the last mile distribution ourselves. We offer solar systems to households, systems to small commercial industrial clients, and we're testing productive use appliances. Think about solar pumps as well as e-scooters. The hardware that I just talked about is always flanked by an inventory financing solution to our B2B partners and a consumer financing solution to the end client. So in that case, she has the option to pay for the system in monthly installments of up to 36 months, and once paid off, she owns the system. We believe that in order to scale and maintain control, we need to digitize the business as much as we can. Therefore, we are very tech-driven, and we are developing our software solution in-house. We're currently present in 5 countries with our own teams. We had a revenue of 2.6 million last year, 30 active B2B partners, 35% returning customers, and we raised a total of 10 million as of today. This is a quick hello from the team. We are now 61 people across 5 markets in Africa, namely in Zambia, Ghana, Togo, Namibia, and Cameroon. I'm proud to say that we have a number of shareholders, lenders, as well as clients as strategic partners that you can see here. And we are already profitable, or EBITDA profitable in our first markets. We plan to reach profitability by end of this year, hitting a revenue target of 3.8 million. Goes without saying, we're currently raising a round. So in case anyone in this room is interested to invest with impact, is interested to invest in Africa, please come and speak to me. Thank you very much.
Thank you so much, Manuel, and very clear call to action. Now, I already announced him, but it is time for Joel to enter the stage. Your time to shine in your 3 minutes. Thank you.
Thank you. So, imagine it's early morning, truck rocks up, you've got a container dropping on your site, doors open up, solar panels start rolling out. In about a couple hours, you got power to your site. This could be a construction site, a farm, a mine, anywhere. So this is PHNXX. What we do at PHNXX is we look and build containerized systems that are deployable with 2 to 3 people in about 3 to 4 hours. You can see there. And the idea is once you pull it out, it could be only solar systems, solar and batteries only. It's like Lego. You could have multiple setups to suit what you need. And in those few hours, you got power running to site. Now, if you ever do need to move your asset away because you need to relocate it or it's temporary use, again, with 2 to 3 people in 3 to 4 hours, you can pack the entire system up, move it again somewhere else, and redeploy the asset again. So it's a direct replacement for diesel generation on many sites. So I'm Joel. This is the rest of my team. We've got about 30 over years experience in remote industries. We used to come from the fuel industry where we did systems for Rio Tinto, mining. That's our background. One of the things we found in the industry we operate in is that there is a missing middle. Agriculture, mining, construction, remote communities. Diesel generation is the only means of power because there is no grid, or the grid's not very stable in the areas they work in. So you can have solar on roof, you can build solar farms, but these people cannot get power to it. So diesel generation is the only means of power. As such, we created PHNXX in 2022-23 to create full ecosystems for remote industries. We do the hardware, systems can deploy in all those remote sites. We do the software, looking at energy management systems, asset management systems. We do the servicing of these assets. We also do the financing because everyone understands, like all my fellow pitchers have said, energy is an OPEX system, not a CAPEX thing. So we work with DLL and NG, which is one of our largest investors, to provide financing options for clients. Our systems are scalable, like Lego. You can always grow the units as you need to, and they're seasonal in nature. You can only deploy them when there's peak power needs. So when you have a need for 3 months or 6 months or 3 years on a construction site, you can deploy the asset, and then at the end, we can lease the asset to you, and then we can move it somewhere else again. So there's always a return on investment. You're not gonna be stuck in an asset that you can't use ever again. We're way cheaper than diesel in a lot of places to operate. We're also cleaner and healthier than diesel. And the health aspect is something that people forget a lot of times, that diesel is actually really bad for human health. So in communities, that's where we shine. Ultimately, our mission is to abate 100 megatons of CO2 within the next decade. And we're here at ChangeNOW to look for partners, investors, people to work with us, to help us create ChangeNOW. Thank you.
Won- Wonderful. That was Joel from Phoenix creating ChangeNOW. And next up is Marie-Laure from Pure Carbon Capture. Thank you for being with us.
Hello. As you're here today at ChangeNOW, you've probably already started changing your habits to reduce your carbon footprints. And the first step is to consume less or better. But if we want to reach neutrality, then we need new solutions like carbon capture. Capturing CO2 on industrial point sources of emissions consists of grabbing and isolating CO2 molecules in flue gases before they are released into the atmosphere. It may sound like science fiction, but it's not. Carbon capture facilities have been in operations for more than 20 years. But since then, the capacity globally has remained low and stable. And if we want to reach neutrality, we need to increase that capacity dramatically so that we can capture the equivalent of China's emissions every year. So if this solution is well known and recognized by everyone as key, why haven't we been able to deploy it? The reason there is simple. Current solutions are water, land, and energy intensive. They are also very complicated to operate. Pure carbon capture technology will reduce our customers' emissions by 75%. The solution is basically simple. It works like a kitchen hood. So the polluted air goes through our filters and the CO2 molecules are retained there. So our solution is simple. It allows low energy consumption. It is solvent-free, and it's very efficient even with low concentrations of CO2. The market in front of us is huge. If we only consider in Europe the bioenergy power plants, it is worth about 52 billion euros. And to get there, we have already completed more than 1,000 hours of testing on our filters, and we have built our own capture demonstrator. Our first pilot plant is scheduled for 2029, and then we will roll out our technology to other markets. We are already selling studies to our customers, and we are projecting to make 2 million euros of revenues in 3 years. This pragmatic approach comes from our history. So we are a team of 4, and we have worked for more than 15 years in the aerospace industry. And we wanted to give a new rest to our careers and use our skills and industrial background to drive the ecological transition. Now we are 9 in the team, and we have signed several contracts with companies that are well known in the world of capture. So the next step for the team is finding investors and also industrial partners, because we are about to raise 4 million euros in capital and to be ready for the industrial pilots.
Wonderful. Thank you so much. That was Marie-Laure from Pure Carbon Capture. Next up, we have Nicolas from Voltiris. What is that all about? Please tell us.
Thank you very much. Hi, everyone. I'm Nicolas. I'm the CEO and co-founder of Voltiris. And I'm happy to present to you how we provide renewable energy to greenhouse operators. So high-tech greenhouses provide a lot of solutions for the future of agriculture. And as such, their surface is booming. They have one major problem. They need huge amount of fossil fuel today to operate. And therefore, the growers and the operators of those greenhouses need to urgently conduct their energy transition. Standard solar solutions fail to get adoption in greenhouses because either growers lack available space to deploy, or using their greenhouse to deploy solar panels is not an option because solar panels take away light that is necessary for the yield of crops. At Voltiris, we developed a unique solar solution that allows growers to fully tap into the surface of their greenhouse and combine energy production and crop production without having a compromise on the yield of their crops. To do that, we have developed a spectral filtering technology that filters the light coming from the sun. The part of the light necessary for photosynthesis goes through, and we use the part of the light not used by photosynthesis to produce renewable energy and to power the greenhouse. We have already deployed our solution with industrial growers in Switzerland, Netherlands, Belgium, and France. As you can see, one of the main changes of our solution in the industry is that we're inside the greenhouse. meaning we don't need any building permits to deploy. We're extremely fast to deploy in the agricultural sector. The potential of our solution is that if it works in a greenhouse, it works in any greenhouse anywhere. And therefore, we can tap into the full surface of 60,000 high-tech greenhouses worldwide to deploy renewable energy at scale. For growers, to ensure that they can seamlessly adopt our solution, we provide them an energy-as-a-service solution, meaning that they don't pay for the solar assets itself, they pay for the energy that they consume for their operations. We have already prepared our scaling, so we're already working with leading strategic partners such as 3M, who's also one of our investors, leading utility companies from Switzerland, and greenhouse builders. And we're also working with leading growers throughout Europe that are waiting for a solution to fully scale. We have also built a complementary team of about 16 people, so with key competencies in the field of commercial development, engineering, technology, finance and project development, and also operation and supply chain. And we've recently closed in January 2025 a seed financing round of 5 million that will be used to reach 3 goals. The first one is to conduct our first large-scale project in an operating greenhouse in Switzerland. The second one is about implementing our industrialization roadmap and reach our target performance for our solution. And finally, building our commercial pipeline, as I mentioned, in Europe, but also North America, Middle East, and Asia. Thank you very much for your time, and I'm looking forward to connect with you afterwards.
That was Nicolas from Voltiris. And next up and last of this round of pitches is James from Wild Hydrogen. What is that all about? Please tell us.
Okay. Hello. Imagine a future where every pint of beer that you drink removes CO2 from the atmosphere. Imagine every time you have a shower, CO2 is removed from the atmosphere. Every time you get on an aeroplane, CO2 is removed from the atmosphere. My name's James, and my team and I are making that vision a reality with our company, Wild Hydrogen. There's an elephant in the room when it comes to energy transition. That elephant is molecules. The vast majority of our energy on the planet is in the form of molecules. We're doing brilliantly with our electricity grid, greening it up, but we need to address the elephant in the room, which is the grey fossil fuel molecules, hard to abate. This is what we're addressing. It's a huge market, massive. We have disruptive clean tech in the form of a rising pressure reformer. We've just come out of stealth mode this year. 3 years, my team and I have been working away on this project. This technology takes waste feedstock, it takes grown fuels, it takes agricultural residues. There's billions and billions of tons of these waste molecules that are currently producing CO2 and methane into the atmosphere. We can reform those molecules into useful fuels as an alternative to the fossil fuels in the form of biomethane, hydrogen, and CO2, and also biochar. We're doing this with this reformer, which is 98% conversion efficiency. We don't have lots and lots of waste product or tars. We have no emissions. This is our prototype journey. Millie was designed in my kitchen, tested at Cranfield University. Nano is our lab scale. Micro is our workshop, and Mini is now in the car park. It's 6,000 times bigger. It's not big enough. We're scaling this technology up quickly, at pace, and proven. What we're asking for today is £3 million to close our seed round. Then we're looking for a Series A very quickly next year. This is the factory where we're going to be building this technology, and we will be a gigacorn by 2035, no doubt. We've got great market traction already, just come out of stealth mode. We have Wales and West Utilities paid pilot on board. We have Suez. I'm pleased to announce at Paris, we have Suez on board, just signed yesterday. Please come and be part of our journey, and we'll shrink the elephant together.
Wonderful. You can stay with us. You can stay. Thank you. Thank you. Addressing the elephant and removing it from the room. Just like last time, I would love to ask the speakers to come back on stage, maybe to my left and to my right. And as before, we have about 8 minutes or so for some questions and answers. So over to you, esteemed jury.
Should we start on this side this time?
Yes?
Okay, for failings, Finks. Are you just integrating all of the different hardware and software? Or are you actually also manufacturing or developing any of it internally?
So what we do is we have partners that do our manufacturing for us.
A little closer.
Sorry. We have partners that we actually do manufacturing with. So we do the design, we've got the patents and everything. We do the supply chain. So for us, we are agnostic to things like battery systems or solar and stuff. We can work, for example, NGOs would say we want this, let us, we'll compile it together as long as it fits our form factor. So we do the system design, we do the ecosystem around it. So obviously the software build, that's ours, and then we deploy the assets. So for us, we look at a whole ecosystem approach to standalone power systems. So solar, battery as a starting point, but even things like wind, if you need grid power, hydrogen generators, we could incorporate everything. So it's the solution for us that matters.
For Voltiris, what is the budgeted cost per unit or per meter square of the asset?
So usually we resonate in cost per watt peak, right? What we aim to reach by the end of this year, and of course it's a project cost, meaning that it takes into account our own technology, but also installation, also inverters, cabling, etc. We aim to reach about 1.3 euros per watt peak if we were to deploy in Europe, and of course it's dependent on the different countries. One key point here is also our unit economics rely on self-consumption versus selling to the grid. And the key part is we're not comparable with regular source solutions because regular source solutions don't have access to the greenhouse as we do. And that's the key part of our solutions, really the behind the meter element and selling back to the grower via an off-take agreement that we have with them. Does that answer your question? Yes.
I have questions for Pure. So I'm curious, what happens to the CO2 after you filter it? Do you need to regenerate the filters? How and where do you dispose of the CO2 after capture?
So thank you. A lot of questions. So the first thing is it depends on the CO2 that you're capturing. Depends on if it's biogenic or not. So it's something that we work with the customer, depending on where it's located, how much you capture at their sites, and so on. But we look at the full picture to make sure that we won't bring the CO2 up to a food quality level and then store it in the soil, because there are things that you're paying for that you don't need to do. So we are looking at the thing to have the full picture, but also think about local way to reuse the CO2. And then the second question, what do we do with the filters once they're full of CO2? So that's part of our technology. We design not only the filters to make them very dense, but with low pressure drop. We also build the whole system around it and integrate it into the system of our customer, because we use heat to take the CO2 off the filters, and we have waste heat in industrial sites. So we are using that heat to make it as efficient as possible.
I have a question for Wild Hydrogen. Thank you very much for your presentation. What is your business model and your vision for coming years?
Yeah, the business model is to produce this technology. It's modular, so we're going to be building it in that factory. We'll be into revenue in 2028. We're expecting to take our first orders next year for that. And as I say, the modular scale of the modular nature of the technology means that we can scale up pretty risk-free. Once we've built one plant and done that well, we just got to churn those plants out. In the same way that solar and wind has decarbonized the electricity grid, we'll decarbonize the gas grid with embedded modular gas generators.
Thank you.
I also have a question for Wild. Does your technology work with any kind of waste? you mentioned that you're transforming waste into hydrogen.
Yep.
And does it work with specific waste or any kind?
So we're working with Suez on all of their waste streams. They have about 14. That includes SRF and black bin bag waste, we call it in the UK. And so far the results are really, really promising. So anything that has an organic or plastic nature to it that has a hydrogen or a carbon component, we will convert that.
Thanks.
Thank you. I also have a question for you. How does it compare to current digesters?
Significant improvement, about a 5 to 6x improvement on conversion. And we have no digestate to deal with. That's the beauty. So there's all the microplastics disappear. There's no microplastics and no digestate. We just methane, hydrogen, CO2, and biochar are the 4 products that we make.
I have a question for MPower. What is your biggest kind of soft cost barrier to scaling? Your biggest soft cost, I mean, is it on the currency issues, financing, a lack of data on customer payback?
Biggest challenge so far has been access to working capital. And that's also what we're raising. We're raising a $4 million working capital facility. The second biggest risk to our business is managing credit defaults. We have taken a relatively cautious approach in financing end clients. We're primarily going through payroll deduction, and we currently have a default of 1.4%. We partner with local banks and MFIs for them to finance the end clients, and roughly 40-50% of our clients, we are financing them ourselves. But we always provide a consumer financing solution, either by us, we're very careful about defaults, or by banks. The third piece is increasing the team. We're now 61 people, increasing the business, scaling the business, really managing that growth phase at the moment.
I also have a question for hydrogen. So you've said your systems are modular, and you've said that you're taking waste feedstock, ag residues, etc., as feedstock. Are you going to have to calibrate every single application because the feedstock is going to be very variable for each use case, or is that not a problem?
So far, the prototypes are suggesting that we're really agnostic to the feedstock. We're using extremely high temperatures and high pressures, and that reforms using supercritical water into those molecules. So we're taking very complex molecules and turning them into very useful molecules as an alternative to fossil fuels. Another point just to make on the ADs, we can take a much broader range of feedstock. So we can take woody material, plastics, and they can be wet as well. So in fact, wetter the better. So we're looking at effluent streams and all sorts. And we're going through a lot of testing with lots and lots of different feedstock. So far, it's looking really very promising indeed, which is why we've attracted the likes of Suez and Wales and West.
Okay, wonderful. We have come to the end of our time for the Q&A. Please put your hands together again for these 5 wonderful individuals and the 5 that went before them. There is 3 things that I want to quickly share. Number 1, the jury and the pitches. You will all have the chance to meet in the networking area just behind here for a little continuation of your conversation. Number 2, the jury, you will have the chance to vote for your favorite pitch, in French called the coup de cœur. Everything sounds a bit better in French. So please look out for these little pieces of paper. And number 3, we are going to start with another round of pitches, this time on food and agriculture in just a few minutes. So stay tuned. We're going to continue in just 3 or 4 minutes. Thank you again for this wonderful first session. Thank you. Thank you. Thanks. Merci.